Hello everyone, you are on Vectarly, and today we are going to solve the last set of problems from COM and collisions. These problems seem to be usual, but let's do it in the right way. Find the center of mass of an object, which is a paraboloid, which is formed by rotating a parabola x is equal to ky square above the x-axis and height of the object is h as shown in the figure. Assume the object is of uniform density. Okay, now let's first come to this question. This question tells that they are rotating the parabola x equal to ky square. As you have encountered conic sections in your math, if you draw x equal to ky square, the graph would be something like this, right? So now what we're doing is we are rotating it about the x-axis. Okay. So what we get is called a paraboloid. Now, if you see the mass, if it is of made of uniform density, the mass above the x-axis and the mass below the x-axis will be same, correct, due to symmetry because it is rotating about the x-axis. So the y-coordinate of the center of mass would be 0, correct. Also, if you see, if you cut the each and every cross section, okay, it is a perfect circle, correct. So as it is a perfect circle, the center of mass of this would be along the center axis, right? That is the x-axis. So the center of mass has only x coordinate. If you integrate the y coordinate, if you find the y coordinate of center of mass and z coordinate of center of mass, it would be 0. So just we are going to find the x coordinate of center of mass. So XCOM is nothing but integral of x dm by integral dm. This is the formula we know, right? So and to simplify it, we are assuming the density to be rho. So what are we going to put is dm is nothing but density into volume, right? dv. Now dv is nothing but area into the thickness dx. Okay, what is the area then? Area is nothing but the area of the circular cross section. So which is pi into y square because this is y, which is the radius, which is nothing but rho pi. What is y square? Y square is nothing but x by k into dx. Okay, this is the equation for dm. Now xcom is nothing but integral of x dm, which is rho pi x by k into dx whole divided by integral of rho pi x by k into dx. Now limits matter. The x goes from 0 to h. So let's write 0 to h over here and 0 to h. Since these rho pi by k are constants, we can cancel them in our next step. So what we get is integral of 0 to h x square dx whole divided by integral of 0 to h x dx. So which is x cubed by 3 plus c and x square by 2 plus c. Since we are doing indefinite integrals, the c gets cancelled. So what we get is h cube by 3 minus 0. So h cube by 3 and here h square by 2, and finally what we get is 2 by 3 h. So the x coordinate of center of mass is 2 by 3 h, which matches with the answer. Now this is a very much simple question. The main thing you have to do in these kind of center of mass finding questions is you have to just approximate where at which points you get the center of mass is 0, because in this question we have y coordinate of center of mass 0 and z as 0. We have to check the symmetry too, which will simplify our steps. If I integrate the ycom, I will get 0. Okay, that is an unwanted step. Similarly, we have to define this properly. Dm is nothing but rho dv, right? We have to assume the required things rho, so at last we don't get it. And all these things are which will come based on your practice. You have to practice more number of questions like this. Okay. Question number 2. A massive frictionless cylinder of radius r. This is a massive frictionless cylinder of radius r moving with a constant velocity u1. Okay. Collides elastically with a small light ball moving with a velocity u2. Okay. Towards the cylinder perpendicular to its axis as shown in the figure. So the axis is going inward. Okay. So we couldn't see it in the figure. The distance between the lines of motion, which is the impact parameter of the body, is b. The impact parameter is nothing but the perpendicular distance between the velocity vectors. Okay, this is moving in this direction, this is moving in this direction, this is the perpendicular distance, that is called impact parameter, which is b over here. Find the speed of the ball after the collision. Assume gravity free conditions. Okay, so we are not neglecting gravity in this situation. Okay, and this mass is much greater, so after collisions this velocity will be same. That is the main point we have to conclude from this line. Okay, a massive frictionless cylinder. Okay, this mass is very much big. Okay, so it won't change its velocity even after the collision. So that is the main point over here. So just before collision the image would be like this, correct? So this is r, which is the radius, and this is the impact parameter b. Now if I'm assuming this angle as theta, okay, so what I get is, uh, since this is moving with u1 velocity and this is theta, this is u1 cos theta and this is u1 sin theta. What about this? The same, this is u2 cos theta and this is u2 sin theta, and u2 will be along here. And just after collision, what happens is the velocity of the ball will only change along the line of collision, right? So the v2 will only change. That is u2 cos theta will only change to v2. And since this is massive, this velocity won't change. Understood? Okay. Now if you see, this u2 sin theta will remain same. Now, as I was saying, E, the collision is elastic. So we are going to apply coefficient of restitution is 1 along the line of collision. The line of collision is nothing but the radius vector. Okay. So how are we going to apply? Now velocity of separation. So what is the velocity of separation over here? So v2 minus u1 cos theta. Correct. I'm assuming v2 minus u1 cos theta, which is the velocity of separation. Okay. And what about the velocity of approach? So the velocity of approach is nothing but u2 cos theta plus u1 cos theta. Okay. So which is u2 cos theta plus u1 cos theta. So velocity of separation by velocity of approach is nothing but 1. So what we get is v2 is nothing but, if I put this over here and take that to the right, 2u1 cos theta, okay, plus u2 cos theta. Makes sense, right? So now what are we going to do is, we know the v2 and this thing. So these things are perpendicular, right? So they're asking the final speed. So we're going to take the magnitude of these two vectors. So final speed of ball is nothing but under root of v2 square plus u2 square sine square theta. Okay, so again under root v2 square, what we get is 4u1 square cos square theta plus u2 square cos square theta plus 4 u1 u2 cos square theta plus u2 square sine square theta. This is also under root. Okay, so I'm just saying under root these two will combine, get u2 square plus, from here I get 4 u1 cos square theta into u1 plus u2. Okay, this is the final speed, okay, which they are asking. And we have to say what is cos theta, right? So what is cos theta? Cos theta is nothing but, some distance. This, what is this distance? Under root r square minus b square, correct, whole divided by r. So this is what cos theta. So this, if you substitute this over here, you get the final speed of the ball after collision. So the thing we are going to understand from this question is nothing but, since if there is a keyword massive, this velocity won't change. That is the first point. What is the second point? The second point is always the momentum transfer occurs along the line of collision. Correct. So the velocity of v2 will only change. That is what the conclusion from this question. Question number 3. A small ball of mass 1 kg is placed in a closed box of mass 2 kg and height 80 centimeter that is placed on a pan of weighing machine as shown. The ball is projected upwards with a velocity u of 5 meter per second. If all the collisions are perfectly elastic, find the average force Ft and Fb exerted by the ball on top and on bottom of the box and the reading W of the weighing machine. Assume that the box does not lose contact with the pan. Okay. Now what happens is this ball is going colliding up, down. Again, it repeats. Actually, this is elastic, right? So the energy cancels. It goes on repeat mode. And uh, upon all these collisions, this box remains in contact with this pan. So let's keep our frame with respect to this box. Okay, because anyway it's not moving, right? So this is same as the ground frame. So what happens is initially its velocity is u, it goes up with velocity v at this point just before collision. Just after collision is also its magnitude of that is speed is also v, because this is an elastic collision, right? This body is at rest, so velocity of separation is v, velocity of approach is also v. So we get the ratio as 1, which is elastic. Okay, the same thing appears here. So if you see over here, first we have to find what is the velocity value v. So if you see, acceleration of due to gravity g is acting downwards, right? So the final velocity v square minus initial velocity u square is nothing but 2as. So minus 2g into h, because g is negative. That is, here it's retardation, not acceleration. So v square is nothing but u square plus 2gh. And what about v? V is nothing but under root u square plus 2gh. We are taking the positive value, okay, because we have marked the directions properly, and this is just the magnitude v. Okay, now what happens is, for let's calculate the time taken to travel from here to here, because as we are asking the average value of the forces f top and f bottom, it's nothing but the we have to take change in momentum by time. Okay, since the force is by definition, force is nothing but change in momentum by time. Okay, now what happens here is they are asking about the average force, so we have to take the time between these two collisions. Okay, that is nothing but the time taken by the ball to move from here to here, correct? So what about that time? Let's calculate. S is equal to ut, and this gets complicated. Let's put this one. V is equal to u minus gt, right? So v minus u, which is u square. Sorry, this is supposed to be minus. I'm making so much errors. U square minus 2gh. Okay, minus u is nothing but minus gt. So if I take gt is nothing but u minus under root u square minus 2gh. So what I get is t is nothing but u minus under root u square minus 2gh whole divided by g. So this is the overall time taken by the ball to reach from bottom to top. Okay, now let's calculate the ft. So ft is nothing but the what is the change in momentum? The impulse given by this particular wall on the ball is nothing but 2m into v, correct? So 2m into what is the value of v? So which we calculated, which is under root u square minus 2gh. Okay, whole divided by what is the time? U minus under root of u square minus 2gh whole into g. So this g comes over here. This is ft. What about the fb? The force at the bottom. The bottom force is nothing but the same. 2mu, okay, which is 2mu, because the change in momentum is 2mu by total time. u minus under root u square minus 2gh into g. Now, if you see on a whole, ft acts upwards and fb acts downwards, mg acts downwards. So the average weight value of w measured by the weighing machine is nothing but fb plus mg always acts downwards, minus ft, right? This is the average value. So what are we going to do is, we are going to substitute the values which we found. So mg plus fb is nothing but 2mug by u minus under root u square minus 2gh, and ft is nothing but 2mg into under root u square minus 2gh whole divided by u minus under root u square minus 2gh. So if you see, the whole term becomes w is nothing but mg plus 2mg. So which is actually, we made an error over here in time. That is, it's supposed to be uh, the overall time between the successive collisions of this. So this reaches up, comes down. Okay, the total time between the successive collision of these two things is nothing but the 2t, the time interval of going up as well as going down. So which is twice of this. Actually, I made an error over here. So this 2 gets cancelled everywhere. So I won't get this 2 over here, and I get just mg. So m plus m into g is nothing but the average weight, that is w. Question number 4. A small block of mass small m is placed on a plank of mass capital M, which rests on a frictionless horizontal floor. Coefficient of friction between the block and the plank is mu. The block is given a sharp impulse so that it starts sliding on the plank with an initial velocity u. Due to the friction between the block and the block slows down and finally stops sliding on the plank. What average thermal power is dissipated in this process? So, this is not a COM in collision problem, but a similar problem from work power energy, which I did not include there. Okay, here what happens is this mu g is nothing but the acceleration due to friction, which is opposite to the velocity over here. If you notice the thing, friction always opposes the relative motion between the blocks. If two blocks are there, okay, if these two blocks are here, what does friction do is, if this is moving with the velocity u, okay, let's suppose this is moving in this direction, friction will try to, the friction force on this block will try to move it backward. It will try to reduce the relative motion. With respect to this frame, it is moving in this direction, right? So this will experience a friction force in this direction. Okay, so it will try give an acceleration in this direction for the larger block. Okay, the force is mu mg because mu into n, the normal reaction is mg. So here acceleration is mu g and here is mu mg by capital. So now what happens is, uh, when does the friction stop? Actually, what happens is the friction stops when there is no relative motion. So not to stop the relative motion, both should have the same velocity, right? So the velocity is nothing but u minus mu gt is the velocity of this small block, and which is equal to the velocity of this thing is mu mg by m into t. So which is u equal to mu gt into 1 plus small m by capital M. Okay, so what we get as t is u by mu g into 1 plus small m by capital M. So this is the time at which the relative motion stops. Okay, the what are they asking is the power, thermal power dissipated in this process. If you notice, the energy lost by the friction is always in the form of heat. So what they are asking is the power of the friction force. Okay, now the power is nothing but the work done by time. This is the overall time. So we have to calculate the work done. So in order to calculate work done, we have two steps or two methods, not steps, two methods. The first one is the conservation of energy. So what happens is initially there is some amount of energy, which is only the kinetic energy of the block of mass small m. So energy initial, which is E initial, is nothing but half mu square. What about the energy final? So energy final is nothing but the combined velocity of these two blocks, half of small m plus capital M into final velocity v square. So their difference is nothing but the energy dissipated in the form of heat or the work done by friction. What is the method 2? Method 2 is nothing but we know the acceleration due to friction or the frictional force. We have to find how much distance this block covers, which is x1, and this is x2 in the time t. We found out the time t, and we know the velocity and acceleration. So we can find x1 and x2, and we have to multiply it with the friction force, so we get the work done by friction. That is the heat dissipated. So this second method is a lengthy one. The first method is a short one. So we have to first find the value of v. So v is nothing but the same mu mg by m into t. 1 plus small m by capital M. Okay. So v is, if you cancel mu g, so and m goes up, you get mu by m plus m. This is the value of v. And work done by friction, which is delta E in negative direction. Sorry, negative sign. Because work done by friction is negative of the difference in energy of final and initial one. So what I get is half m u square minus half m plus m into v square. What is v square? M square u square by m plus m the whole square. So from this I get half, I will take half mu square as common. Okay, so what I get is 1 minus this 1 m plus m cancels the square 1. So what I get is 1 minus m by m plus m. Okay, so the work done by friction on a whole is half capital M into small m by capital M plus small m into u square. So this is the work done by friction. Now what are they asking is the power. So power is nothing but work done by friction by time taken. Correct. So what is the work done by friction? Half m by m plus m into u square. Hold on, right? What is the time taken? The time taken is nothing but u by mu g into 1 plus small m by or capital M plus small m into small. It's capital M, sorry. So this becomes capital M over here. Okay, so this term gets cancelled and this capital M also gets cancelled and this u gets cancelled. So this mu g will go to the numerator. So if you see small mu mu g by 2. So this is the power. This is the thermal power. So which is option A. So the thing which this question taught us is nothing but simply we are going to calculate thermal power dissipated in this process. But here what we have to consider is the main concept of friction, which is it always resists the relative motion between any two bodies. Okay, when the relative motion ceases, the frictional force also ceases. There is no frictional force. So we have to calculate the time until we get that particular situation and calculate the remaining things as usual. I hope these set of questions would be, most of the questions are much easier, not up to the JEE Advanced level 2. But these questions have some important concepts which must be revised frequently. So try solving more COM and collision problems. Okay, I will be uploading the PDF of all these questions. Try solving them without seeing the solution and learn the methods of solving. Thank you for watching this video. Stay tuned with Vectavia.